Okay, wait. Probably let's start. The first part is not that interesting. Um, yeah. So thank you all for joining me. My name is Mikhail Sveshnikov. I work for Iterative, and I am MLEM lead developer. So MLEM is our newest open source tool for model deployment. And today I will tell you more about it and show you how to use it. So yeah, our plan for today is I will tell you what MLEM is and the reasoning behind it, and then I will tell you what you can do with MLEM. And after that, we will have a live demo slash workshop slash tutorial that you can follow along if you want to. And you will see firsthand how to use MLEM in real life scenarios. Not that real life, but close to real life. So yeah, let's start. First part is about MLEM and what is it. And you probably know that MLEM is a famous internet meme when your pet sticking its tongue out. And of course, it's not that. Uh, Actually, MLEM is an open source tool by Iterative, and it provides easy and flexible way to package and deploy and serve your machine learning models. It allows you to codify your models and transform them into Python modules or Docker images or deployable services programmatically. And also MLEM defines standard interfaces and formats for models and data sets, and it has modular and flexible design. This allows us to support a wide variety of model types, of dataset types, deployment targets, packaging formats, and so on. Okay, let's talk about motivation. Previously, I worked as a data engineer slash MLOps engineer, and one of my responsibilities was to take models from data scientists and make them work in production. And when I'm saying make them work in production, I mean that I wrote a bunch of wrapper services and tried to integrate them into existing IT systems. Typically, it was like some Flask application that will read a pickle file, then create an endpoint like predict or something like that, and it will expect some JSON. Then it deserializes this JSON into, for example, pandas data frame or something like that. Feed it to the model, get a response, serialize the response, and send it back. So very simple thing. And all of those wrappers were pretty much the same, except of course the model changed and the set of features changed. But other than that, they were like exactly the same. So I thought to myself that since I'm lazy and I don't want to do like repetitive work, I should automate this. And voila, some years later, we have MLEM now. Um, yeah, but to create a service from your model, you need to know a lot about it. For example, if you have a model file, you need to know how to read it because it might be pickle file, but it might be something else. Yeah, and you don't know. You also, of course, need to know runtime requirements for this model, like libraries and versions of those libraries, environment variables, and stuff like that. Because if you're trying to load, for example, XGBoost model, you need XGBoost installed, of course. Also, you need to know a list of methods that this model has, because some of them have like predict method, some of them has like transform method or run method or something like that. And maybe they have multiple methods like predict and predict proba, and you don't know which one you should use. And for those methods, you need to know their signatures, because maybe some of them expects like numpy array, some of them expects pandas data frame or something else, and you need to know that. And of course, for those arguments, you need a way to serialize them, because if you're spinning up like a HTTP server or something like that, you need a way to serialize and deserialize JSON that you get from your client and turn it into Pandas data frame, or basically the type that model expects, of course. And yeah, and we don't want to provide all of this manually, because humans make mistakes, right? And to do this automatically, you need to intercept like live Python object in memory and inspect it and see what it does, what it has, and only after that save it to file. That's why there is like two parts to MLEM. And the first one is codification. It's when we analyze the Python object and extract all the necessary metadata that I described. And we save it as a regular binary, one or multiple binaries, and additional .mlm file that contains all the metadata that we collected. And together, all of those files we call like MLEM object, or MLEM model, or MLEM data, or something like that. And after you have this MLEM object, you can use it to package the model, serve it, or deploy somewhere in different scenarios. So a bit more on MLM objects. Assuming model is a fitted model from one of the supported frameworks, and in Python, simple mlm.api.save method will produce those two files. First one is model.mlm. It's a YAML file with all the metadata that I described, like it's which framework you used, how to read the file, which method does it have, what are the signatures, requirements, the frameworks, the versions, and so on. And the second file will be model, just model, and it's a binary containing the model itself, and it's produced by framework native IO implementation, meaning that if this framework like XGBoost or LegibBM or something like that have its own method to save models, we will use that. And if there is no such method, we will use like pickle or something common. And important note that data sets also can be saved the same way. Why this is needed, I will explain to you later. Oh yeah, and there's a third part of MLEM, kind of secret and non-obvious. So of course, each ML project is unique, and it has its own like requirements and its own workflow and its own use cases and so on. So we can have one fits all scenario. Okay, so that's why MLEM has plugin system that allows you to customize basically every part, every component of MLEM, starting from like support for new machine learning frameworks, and ending with like different serving, different packaging, maybe different deploy environment, and so on. And actually, all the built-in implementations are also MLEM plugins, but they're just shipped with the MLEM code base. Yeah, and the last thing about like theory of MLEM is that it's designed and built with GitOps approach in mind, like other iterative tools. And using iterative tools together will get your even more GitOps goodness. For example, if you're using DVC, you can version your model artifacts, model binaries, if you will, without polluting Git, and store them in some remote cloud file storage. And if you use DVC pipelines, you can use MLEM CLI commands as a pipeline stages that will save you writing some code. Also, we have this GTO tool. It allows you to tag different commits and different files in those commits as some versions of your objects, and define different stages or environments, like production, staging, testing, development, or something like that, and transition your objects between those environments to get you like GitOps representation of your deployment target environments, right? And you can use that to choose the right version for your deployment. And of course, we've got Studio, which is a nice UI for all of those tools. And you can see like DVC files and metrics there. You will, in probably next release, you will see GTO versions and MLEM metadata from your models there too. So using those tools together enables you to build like a full-scale model registry with all the nice features based on GitOps approach. And you can read more about it. I lost the link, but it's I don't know if you can see, it's Iterative AI/model registry. You can go to Iterative AI website and see the solutions tab there. Okay, let's move on to the next part. And I will tell you what you can actually do with MLEM. So typical MLEM workflow is looking like this. First, you train your model like you always do. You don't need to change any code there. Then you save your model with MLEM, turning it into a MLEM object instead of like dumping pickle file or something like that. After that, a bunch of question marks, and then you got profit. And question marks means exciting stuff in Dogolingua. And in the next slides, I will go through all of this stuff in ascending order of excitement. So the first level of excitement is plain loading, of course. You just use MLEM API load method to load the exact same object that you saved. And you don't need to specify anything else, just only URL or URI. And it's framework agnostic, so you use the same method for all frameworks, like is it scikit-learn, is it EasyBoost, it doesn't matter, we will load it properly. As URL, you can pass some cloud URL or web URLs, so you can load your models or data sets directly from S3, for example, or from GitHub, and or from next version will have GitLab, and I think we're releasing that today, and Bitbucket also. Yeah, and if you use like a Git repository that is in some remote location or locally, doesn't matter, you can specify revision that you want to use, and you will load different versions of your model. And of course, we support DVC tracked files. So if the binary of your model is in DVC cache, we will load it from there without any additional downloading of those files. And also, we're able to check your Python environment for compatibility, because maybe you have some different version of your library that will break your model, or maybe you have different Python versions, so we can check all of it. Next level is using MLEM apply method via API or CLI to quickly run your model against some data. Basically, it's the same as loading, but together with running some method. And of course, it has all the level 1 tier features because it's basically the same, but MLEM will handle loading of your model and loading of your data, and it will save the results also. And if you use it via CLI, you don't need to code anything, because you just run some CLI command. Sorry. Okay, so there's a question. I'm not showing the first slide. Please, someone write if you're seeing the level to apply in slide. Okay, so yeah, thanks. Yeah, but please try rejoining or just refresh the page. It helps. Yeah, okay, let's continue then. So next level is serving. It's when you take your model and spin up some server, maybe HTTP, maybe something else, and that will serve your model, of course. And the features of this level is you don't need additional code to set up servers. So you basically don't need to write actual Flask, or actually we're using Fast API now. You don't need to write Fast API code, and we will automatically convert your model methods into endpoints, and we will automatically serialize and deserialize requests and responses. And if you're using Fast API, you will get this nice open API schema and documentation page, and I will show you that on the workshop part. And also we have RMQ, which is async serving with messaging. So and we will implement even more in the next releases. So yeah, next level is build model packages, or you can say that you just export your model to some different format of your choosing. For now, we have exporting to pip package. You can create a directory with all the Python package stuff like setup py, some metadata, and the actual code. Or you can build a wheel file directly, and I will show you that in the workshop too. And we can build Docker image from your model using some of the servers from previous level. And of course, we're going to implement more soon. And the final level 5 is deploying your model to cloud. So basically, you describe your target deployment environment, and with one API or CLI call, you spin up a service in the supported cloud. And you don't need to go through cloud interface or APIs or consoles. You can check how your deployment is doing later with the MLEM command. And you can also make requests to your model as if it was local. Basically, we will handle all the serialization for you. And this level is actually so exciting. It's still considered experimental. And for now, we support only Heroku, but AWS support is in the works. And basically, in next major release, we will rework this to be even better. Okay, so we're almost in the demo time, but first I want to share our future plans. So first thing first, we will fix existing bugs, and of course add some new ones because we need something to fix later. We will add support for more model frameworks and more data types, and more packaging formats, more serving protocols, more deploy targets, more everything basically. And as I said, we will improve deployment state management. This is what I'm talking about in the previous slide. And of course, we will provide more excitement. So yeah, that is it. If you have questions, I will answer them. You can write them in chat, and then we'll go to tutorial part. And actually, if you want to follow along for tutorial, I will send you the link for notebook that we will be using. Yeah, it should be in chat now. Yeah, and please, if you have the time, go to MLEM repo and give us a star. That will be very helpful. Yeah, we plan to support, of course, all major cloud providers. It's SageMaker, AWS, uh, Google Cloud, Azure, of course, maybe something else, but those three are like the top ones. We're doing AWS first. Yeah. Also, we will support not like general clouds, but some specific solutions like Seldon Core or just plain Kubernetes or something like that. So maybe if we don't have Azure support, but we will have support for Azure Kubernetes cluster. I don't remember how it's called there, but something like this. Yeah. Yeah. Okay. So if there's no more questions, we can go to tutorial. And if you will have questions later, of course, I will answer them after tutorial or maybe during tutorial. And as I said, we will be attending the main event in real life physically. So I will be at Iterative booth, and you can come and talk to me if you have some other questions. Let me see if there is some coordinates that I can give you for that. Yeah, our booth is G3. Okay, so let's start with the tutorial. I will make this a bit bigger. Okay, so I will be using this Jupyter notebook, and I sent you the link in chat, or you can just repeat after me. So I prepared some code, and this is actually not run, so I already installed all of this, but this directory is pretty empty for now. And yeah, as I said, first thing that we do is we train some model. And for this tutorial, of course, we don't have some big model, but yeah, we just load iris dataset from scikit-learn and like train simple random forest classifier to work with. Okay. And the second part, as I said, is you save your model. And for that, you import mlem.api.save method. And you call this. And you provide the model object, of course, and the name of your model. It will be used as a file name. And this will be the name of your MLEM object. Also, you provide the data that your model expects, so MLEM can like inspect it too and add the metadata about your arguments to the model. Yeah, and there are some additional arguments that you can give. We'll see. There is this path, project, file system, index. So there are a lot of them, but we don't need them yet. So, okay, we run this code, and what we've got is, okay, yeah, those two files, as I promised. The first one is binary with the model, and this one is metadata. And let's see what we've got. So we've got this YAML file, and it has all the data that I described in the presentation. And yeah, let's just see it as a dictionary, because this metadata is actually just serialized model object, and model object is what we've got as a result of the save method. And this model object, it's yeah, let's see it. It's actually a Pydantic model. If you're familiar with Pydantic, it's like a serialization library, and this object is actually Pydantic model, and it has all the fields there. And if you just call model.dict, you will get serialized version of this. And this is what we basically write into the YAML file. So yeah, we've got the description we provided. We've got artifacts, which is like the files the model consists of, and we have, of course, only one file. But yeah, if you're saving like some I don't know, neural network with different files for graph, for weights, and for something else, like different checkpoints or something, we will have multiple files. Yeah, next we have the requirements that we collected from this model. And next thing is pretty big. It's model type. It has the implementation, the framework that we used. It has the signatures of all the methods and the way to save model. Yeah, so we see scalar here, and the object type is model. Yeah, and the binary file is pickle, because for Skylearn we use pickle, and you can just read it like regular pickle. You will get the same object, or you can use artifacts field that has this open method, and this will open the same file, and you will get the same pickle file too. Yeah. So the question about MLEM is agnostic to how the model dict looks like, right? So yeah, this dictionary is composed by MLEM, so you don't have you don't have to fill it yourself. But yeah, we support different frameworks. So let's try some other model type. I don't know if I have installed something else, but actually, oh yeah, it's a good good question to show that we support Python callables, for example. So if I have like this, I don't know, rf2 data, and it will just return the same predict, for example, right? Yeah, I can make a model out of it. I don't want to save it, so I will do this instead. So yeah, we created the model from a Python function, and as you can see, oh, let's do it like this. See better. So yeah, we've got different type, right? It's callable now. It was Skylearn, and we've got some changes in signature because now it's only one method call. Yeah, but we still got that Skylearn is a requirement, because inside it has like Skylearn model, and we got NumPy and all of the stuff. Yeah. Okay, let's return to the tutorial. so we finished here. I was telling you that this RF file is just a pickle file. Yeah, and model metadata also has requirements, and it has some nice to-pip function. So you can just run it like that. For example, you will get the exact versions that were used for this model. Yeah, and we also collect not only Python requirements, but also some packages need to install some system libraries, like EasyBoost needs libgomp, if I remember correctly. So we will collect that too. Of course, you can't install it with pip, but you will still get it in the requirements. Yeah, and also if you use some local files that are not like pip installable, we will collect them too and put them inside the metadata, so you will be able to read your model like in different environment, for example, in Docker image or something else, somewhere else. Yeah, and actually, there is a feature that was requested, and we'll be adding it soon. We will probably have some CLI command like MLEM, I don't know, create and some model, and it will create environment for your model that will have all the necessary requirements. But for now, we don't have that. It's like foreshadowing. Yeah. So let's return to model metadata. The last field that is left is model type. That was pretty big because it has all the metadata about the actual underlying model, right? So we know it's a scalar model, and yeah, we can see the dictionary here. It has the methods field, which has the signatures of all the methods, together with the data types of the arguments and the return types. And we have, yeah, we don't have IO here because it's default IO. Yeah, also the actual model object is inside this model type, so you can access it with the model as model field. Yeah, and it actually has the IO. It's just not serialized because it's default. And for Scalern, we use simple pickle IO, meaning that we just pickle the file. There is another not simple pickle, which is used for callables. As you can see, where is it? Yeah, it was somewhere here. Oh yeah, well, it's here. So this is pickle, and this one is simple pickle, because the pickle for callable models actually tries to find other models inside your function. Like if you're wrote a function that has like I don't know, PyTorch model inside, and we will detect that, and we will save PyTorch model as PyTorch model, and all the rest of the function will be pickled. So this way, we will not pickle your PyTorch function because it might fail, because it probably uses some C bindings and generally not optimal way to save torch model. Okay, let's return to our notebook. Yeah, the model type has the signatures of the methods. For example, we can check out the predict method, and here we can see that the name is predict. The arguments are data, and their type is data frame type, and it should have those models. Yeah, actually, I can show you the actual data frame here. and we can see the column list for this data set. And let me remind you that we collected all of this automatically. So if you provide like NumPy array for your model, you will have NumPy array like, for example, like this, right? But this is a return type, so this model returns NumPy array with the shape of none, which means it's 1D array of type int64, because we have it's a multi-class task, if I remember correctly. Yeah, so the prediction is array of ones, zeros, and twos, and those are the classes of their objects that were predicted. Okay, so yeah, this is some don't need. Yeah, as I said, you can also save data the same way, and I will show you how to do that. So you will use the same save method for your data set, and you provide all the same arguments here. And if you save this, you will get these two files, one of which, of course, is just a CSV file, and one is metadata file. And of course, we collect a bit different metadata about data sets. So we still have description, of course. The artifacts is the file. And we, of course, have requirements, and this needs only pandas because it's pandas data frame. And instead of model type field, we have reader. And the reader is a way to read your file. So yeah, let's show that we have the same requirements. And yeah, let's take a look at the reader. So the reader has a bunch of fields. The main one is pandas, like an implementation of your reader. Yeah, we've got format, and by default we save files as CSV, but there is a way to change that, and I will show you later. Yeah, and the other field is data type, and this is exactly the same data type that we saw here in model signature, right? Because yeah, if we do it like this, we will get the same stuff, right? Like columns, types, and index columns. And here we have, yeah, the same columns, the types, index columns. So this is exactly the same object that shows that this data frame that we will read will have this like signature. Yeah, and of course we can access the actual data in the data field for the data set. And yeah, here I show that this is exactly the same data, right? So you can just read it like plain CSV if you like. Yeah, okay, so next part is about MLEM project. So MLEM project is like a repo or workspace that you're working, and basically it allows you to have some structure to your saved objects and have some different configuration. And typically your MLEM project will be the same as your repository or DVC project or something like that. So yeah, let's remove all the stuff that we don't need. Check that we don't have anything. So this should be iris, right? Okay. So yeah, let's start from scratch. First, we need to initialize MLEM project, and it is done with MLEM init command, and we will have some nice output. Yeah, and now we have this .mlm dir, And actually, MLEM project is any directory that has .mlem directory inside of it. So yeah, this directory for now it contains only configuration file, and it is empty since we didn't set any options. But let's change that, and we can run some MLEM CLI to change the file format for pandas data frames, right? So we want the file format to be Parquet. Yeah, we got confirmation that it's okay. And now if we save the same data, it will be saved as Parquet file. So yeah, the first thing that changed is that now when we save our MLEM objects, they go into this .mlem directory. So yeah, let's see. So we've got nothing here, but we saved 2 objects, right? And we've got nothing here, but we have something here now. And we've got data and we've got model. So data sets go to data file, models go to model file. So if we take a look here, that you will see those 2 files, and we've got the model here. And since we changed the default format for pandas data frames, we can now we can read it with read Parquet instead of read CSV, right? Because this works. CSV, and this doesn't work, of course. Yeah. Okay, so we've got basically the codification part of MLEM. Yeah, there are some more options like indexing, like saving not to .mlem dirs, and so on. But yeah, the basics, we've covered the basics. And now we get to the good part about like packaging, serving, and deploying. For that, MLEM has CLI and API functions. And we've seen a couple of those, but let's see all of them. So to use MLEM CLI, you will call MLEM, and it has a big help message. You can check it out. So it has all the commands. So we saw config, it sets and gets configuration options for you. But actually, you can just edit the config file, which is a YAML file, if you'd like. But this will provide you like validation that your set existing fields with correct types. Init is initializing MLEM project, and basically what it does, it just creates .mlem dir with empty config, as I said. So there's no magic there. Yeah, and a list or ls, which is an alias for list, lists all the MLEM objects in your directory. So yeah, we save 2 objects, so we've got 1 model and 1 data set. Yeah, what's next? Object commands is about manipulating MLEM objects. Clone, it like copies existing MLEM object from somewhere to another place, right? And as I said about like loading, actually most of the CLI and API supports using remote locations. So the clone is needed when you need to like copy some model from remote location, like from some Git repository or GitHub URL or S3 file system to your local machine, or vice versa. You need to send your local model to S3 or something like that. You will use clone. declare creates a new MLEM object, and it it can't be used with models or datasets, but MLEM has other types of MLEM objects which can be just declared, and we will see that later. Import is importing existing files and creating MLEM objects from them. Like if you have a CSV file somewhere, you can import it without loading it with code and then saving it from LEM. You can import it from CLI, but of course this import API is more limited than just saving, because it supports like not every file can be imported, right? Only those which can be read by MLEM into some Python object. And of course, we can read pickle files. We can read all the pandas formats and try to create data frames from those files, and maybe some other. But yeah, generally it's more limited than just saving from live Python process. Yeah, and link command is creating a link from for some MLEM object. For example, if you're linking your local object is just an alias, so you can like have an alias like latest and link different objects to this link name, and this way, for example, you can always from your, I don't know, from your deployment system, you can always just use latest, but the actual models that will be loaded, you can change them by changing the alias where it points to. Yeah, or you can create a link for some remote object, and this will be like a collection of different remote models in your single repository, which actually consists only of links. Yeah. Next, the good stuff, and I will show you how to use those shortly. But yeah, apply is, as I said, you just load your model, load your data, run your model, and save the result. Apply remote is almost the same, but the difference is you don't have your model locally, but you have it somewhere deployed, and you can take your data, serialize it, send to the model service, get the result, and save the result like apply do. Build or export is about building or exporting your model to some format like Python package or Docker image, and deployment is about deploying to cloud. Oh yeah, and serve is about just serving from your CLI or from your Python process, and I will show you all of those. Yeah, and we've got some examples. Yeah, I'll already show you a list or less. And yeah, and API functions are here. So let's see what we've got here. So we've got save, load, and load meta, and I will show you the load stuff shortly. But other than that, we have all the same methods that CLI has. This is because actually CLI is just like CLI wrappers around API functions. So you can either use those programmatically in Python or from CLI. Okay, let's get to loading stuff. For loading, we have two functions. One is load, and one is load meta. So the load function, it loads the exact same object that you saved. So if you saved random forest classifier, you will get the random forest classifier. And load meta actually loads not the object you saved, but MLEM object that you created. So if you remember when we called save, we've got this object, which is a MLEM model. So load meta will load MLEM model. And of course, you can get the actual model from this model, right? But if you use load meta, you will get all the metadata too. Yeah, and note that you can actually use it like this because we have MLEM project here, and you saved it as a ref, so you don't need to provide .mlem/model, and it will be read either way. Yeah, let me delete this. And yeah, as I said, we support like remote locations. For example, you can set projects to something like this, and these are get started repository that we use for tutorial on our docs page on MLEM.ai. Yeah, and you can choose the revision, which can be like a branch, a tag, or just a commit hash to load from specific commit, right? And yeah, let's try and load this RF model in from this repo. Actually, let's take a look at this. Yeah, let's choose this branch. Yeah, and you'll see that we have yeah, this RF model here. And we'll try and load it. Actually, it's the same as the model that we use for this workshop because it was trained with the same code. Yeah, so it took a bit longer than loading from local, of course. Yeah, but it's done, and we can oh, here we can see the location that we loaded it from here. So the path is this one, and yeah, the full path is here. Yeah, and we can see the same dictionary with the metadata, and it's pretty much the same, I think. Yeah, it has all the same methods. Yeah, and to load the actual value, you can first load it if it was not loaded, and then get the value. Or you can access it after it was loaded, as I said, with the model field. It will be the same. Oh, yeah, and of course you can use load method too, like this. Let's just copy this. And use load instead of load meta. Yeah, so you will get the same object here. Yeah, so this remote RF is a MLEM model, and actually it has all the same methods that underlying model have, at least those that we know about. For example, yeah, if you take a look here, yeah, we know about predict proba, and those two methods, they're actually the same method, but with native Scaleron signature. Because for predict method and predict proba, we have fixed signature, which is one argument named data. So let me show you. So for predict, we have one argument named data, and the actual Scaleron model that we have has x as the first argument, and we just want to have the standard interface for models, And that's why we force this argument to be named data, but we have the original signature in here. So this argument name is X, and also it has some additional arguments, I think. Oh, no. We saw that it has only one. But some of the frameworks, I think XGBoost or LightGBM, they have like additional optional arguments that you can provide for predict, and predict method will not have them, and something like GBM predict will have them if you need them, actually. Yeah, and so yeah, those methods that are in here, you can call them directly on MLEM model object, like this, or like this. Yeah. Oh, sorry, it is probe, right? But you can't run fit on it because MLEM doesn't know about fit, at least yet. Okay, so that was about loading, and yeah, of course, if you load model, you're free to use it however you like. But MLEM has some more convenient ways to use models. For example, next thing is apply. Apply, as I said, is when you just run your model against some data, and you don't need to use code to load it or to load the data. And here we can run this CLI command. It will apply our model to the same data set, and will output it as a JSON. Yeah, so pretty much the same output as for Python, but this is actually a JSON that you can capture from this command, or you can save it, for example, as prediction. Yeah, so now you have this data prediction layer. Yeah, and of course you can use it with remote objects. For that, you just need to set the project, or actually also you can use just a full URI here without setting the project, like this. And you can set a revision, and we will use the same local data set. Yeah, it takes a bit of time, but yeah, we've got the same output here. Yeah, and applying is kind of like loading and then running some method. And actually, you can choose which method you want to use. For example, yeah, let's use JSON. Specify method predict probe, for example. And now we have a different output. Yeah, but that's the most easiest case when you just apply your model. Next one is serving. For serving, you can use either API or CLI, like always. API is here, but we will use CLI because I can't run fast API server inside the notebook. I can, but it will be bad. So yeah, to see some options, you can call help, and you see that you need to specify model and subtype of your server. And there are some choices here, but you actually can see what types are available for server with this CLI command. or actually you can see all the types that can be used in some not types, like it's an interfaces that can be implemented. So we have artifact about it's about storing files. Storage is the same. Requirement is like Python requirement or something else. We've got data types, that is a description of data frameworks like pandas or numpy. Data reader is corresponding reader for those frameworks, and writer is again writer. Yeah, so this part is about models, the same stuff, how to read models and their signatures and stuff. Yeah, this is like basic meta class, which is base for MLEM, all MLEM objects like MLEM model or MLEM data or some other stuff. Builder is about building. We'll get to that, and deploy the same. Yeah, and environment and deployment is part of deploy. Yeah, import is about importing. As I said, you can import and you can implement different import types. Interface is about runtime, same as client and server, and actually the server that we need right now. So yeah, let's see type server. And we've got 3 implementation here. And this one is actually we can use, but it's specific server for Heroku deployment. So we've got those 2 options left, and we don't have RMQ server, so we use Fast API. And if we type Fast API here, we will see options that we can use for Fast API. For now, it's just host and port. But yeah, in future we will add more options that are needed. I don't know, like use SSL or something like that. Yeah, let's serve our model. So we use MLEM serve, CLI command. Ref is the model name. Fast API is a server implementation, and the option port equals 80. So default is 8080, but let's change that to 80. Yeah, so we see here that our server has started, and yeah, we can actually go and check documentation. And here we have this OpenAPI documentation. Nice. And yeah, we have all the methods here. We have all the schemas for requests and responses. Like you can see that predict request model is like a data field with this object, and it has values, and the values are rows of those, and those have 4 columns, and this corresponds to our data frame that we use to train. So yeah, and actually you can see here the example of your request. So we will have some values here, and yeah, all the fields that we need to fill up, and you can even try and send a request here. Yeah, this is the response. We got 0, and if you change something in here, yeah, you will get different answer. And you can see that we got those requests here. So those are to predict requests. Yeah, you can play with it. You can copy this curl that you can run from console to try it out. And actually, we also have a programmatic way to make requests, but I can show it to you here because this cell is running. But it looks something like this, that you create a client object from your from the location of the server. It will look something like this actually from okay, let me stop the server from lem runtime for HTTP client, and equals, and here you will have like host equals host, port equals to 80, and then you can call the same methods your model has and provide it with the same local objects like data frames, and it will look like you're just running your code locally, but actually your data will be serialized, sent to this host. Then the model will run. It will give your predictions, and they will be sent back and deserialized into an NumPy array or whatever your model returns. Okay. And in the deployment part, I will actually show you how it works. Okay, next part is building model packages. And for that, we, of course, use build API or build CLI. And this time we will use API. Let's import it. And the same, we can choose what implementations we have, and we have 2 for Docker and 2 for Python package. So the Docker directory is like just setting up the Docker directory where you can run Docker build. It will have like a Docker file, it will have your sources, it will have like requirements, txt and stuff. And the Docker is the same, but you actually run Docker build there after, and you will get ready to run Docker image. And pip and VHL pretty much the same, but with pip you will have directory with the Python package, with setup.py, with something that, of course, sources and your model. And the VHL is the same, but you will get a wheel file that is ready to be installed. Yeah, let's see what we need to do for Docker directory. We could try Docker, but it will be long, since it probably will download all the Docker image stuff and install all the requirements. So Docker directory is almost the same, but it is a lot faster. So to use that, we need to specify a server, because inside your Docker image there will be a server running, and the target is basically a directory where to save it. So we need to use build. We specify Docker directory. We specify our model, and those options, server and target. So if we run this, oh, that was pretty fast. Yeah, so there is some metadata about this Docker model directory, but we can actually just go ahead and see what we've got. So this build Docker directory, it has Docker file, it has our model, it has requirements, and it has run sh. So our requirements is all the requirements of our model, of course, and additionally requirements of the server, because you also need fast API to run fast API. Yeah, if you take a look at the Docker file, you will have like your base image is Python of the same version that you have. You copy requirements, you install requirements, you also install MLEM. Yeah, then you copy the model itself, set some environment variables, and run the sh file. And this sh file is actually just MLEM serve your model with fast API and nothing else. So yeah, if we build this and run, it will spin up the same server as we've got here, but it will be inside the Docker image with all the same environment that you had when you trained your model. Okay, and let's try and build a wheel file now. So for that, we need to specify 2 things. which are required is package name and again the directory where to save it. It has like some additional options, but we will not use them. So let's build a wheel file from our now remote model. And as you can see, you can use either path here, or you can use actual objects. You can even have remote path here, of course, and they will be loaded. So yeah, this package name will be my random forest, and we will save it to build VHL. Let's run this. It will take some time, some pip warning. Oh, that was pretty quick. Oh, that's because we already loaded the model. Yeah. So let's see what we've got here. What we got is just a wheel file, of course, and you can install it. And right after, you can import it and run some methods of your model, or predict it will have all the same methods as your model, of course. Yeah, so it has the model. The model, it has yeah, all the same methods as your model. Yeah, okay, so we've got the final part, but I will answer some questions. The first one is how well does MLEM support TensorFlow? We like working on supporting TensorFlow right now. So actually there is a PR that I will review today for TensorFlow support. So for now we support Torch. Yeah, and we will support TensorFlow probably in next release, or like next release, because we're going to release some fixes today, smaller fixes after initial release that was last Wednesday. So we are only 1 week old for now. Yeah, and for Kubernetes YAMLs, for now we don't. We plan to add support for Kubernetes and for Seldon Core and for Cloud Kubernetes cluster in Q3 basically. So I'd say 1 or 2 months probably, something like that. Okay, so this is the final part for this tutorial, and we will try and deploy our model to Heroku. So for cloud deployment, you need to declare your basically target environment first, and we will, since we use Heroku, we will declare environment Heroku and we'll name it staging. So basically this is what is it about. Yeah, so we save this env to MLEM env staging, and the staging is also MLEM object. So if it was in some remote Git repo, for example, you can access it like, yeah, like other remote objects. Yeah, and here you're supposed to provide some options, like for server. There are other options. For Heroku, it's just API key, and you can get this API key from Heroku dashboard. But if you have Heroku CLI, you can actually log in via it, and you don't need to provide your API key if you have Heroku CLI and you log on with it. So yeah, it's fun. Yeah, so since I have it and I logged in here, I don't need to provide an option, and thus I don't need to show you my API key. That was the purpose of it, of course. Yeah. Now that you have your, let me move this. Since we've got our staging environment now, we can run deploy API or CLI. Of course, it works as a CLI also. Yeah, and for deployment, we need to specify some things. First is environment. There is like 3 fields here, but we can fill only one, since yeah, it's a link, but we can give not the link but the actual object, and the same for model. And the only actually required thing is application name for our Heroku server. If you will be repeating those steps, you need to choose different app name, because Heroku have one namespace for all applications, so you need to do some other name. Okay, so let's deploy our model, and yeah, the signature is the path of your deployment, meaning the path of deployment metadata model. Next, yeah, model environment, and some other arguments, and we provide application name argument here. Yeah, and this may take some time, because actually what is going on? Oh, that was fast. Okay, actually I know, I just cached the previous run, so it was fast. Actually, what we've done here is we created a Docker image with our model that uses Heroku server. Then we pushed this image to Heroku. We created a Heroku application first, and then we pushed the image there, and then we released it. So yeah, here we have some, again, MLEM object for Heroku deployment. It has all the stuff that we saw before, because it has like the model, the environment, the application status, and you can see it here in the service MLEM. And the service.mlem is actually also MLEM object, since it resides here, and you can load it. And you can see, for example, some options, not options, like some configuration. So we've got our server here. You can actually go there, and you will see the same Swagger Fast API, Open API documentation schema. Yeah. So this is down here. Yeah. Yeah. You can see that we got information about Heroku here, but we don't need it. So yeah, I promise that I will show you the client. So yeah, we can for deployment, we actually can create clients not manually, but from the state of the deployment. So this method will give us the client, and yeah, now we let's look. Yeah, so this is the same HTTP client that I showed you previously, but we automatically got the host and the port. Yeah, and you can call the same methods and provide pandas data frame here, and yeah, you can call the proba. You can learn, which fails Oh, yeah, because it has, yeah, it has different signatures, so this won't work with this data. Okay. Yeah, and you can see methods that this client has, and it's the same like set of methods that your model have, and they have the signature, and from those signatures, all those callable methods are compiled. Okay, so we've got like 7 minutes left. This is the end of the tutorial. If you have some questions, you can ask them now. Or again, I invite you to join us at Iterative booth on the main event, which is G3, and we can discuss MLEM or discuss model registries or model deployment or anything else there. Yeah, okay, I'll wait a couple of minutes in case somebody has a big question. But other than that, I think we're done. And thank you all for coming. Yeah, looking forward to seeing some of you probably on the main event and discussing the great future of MLOps and MLEM tool in particular. Yeah, we have iterative booth, and it is G3, and I will be there both days. Probably I will leave for some of the talks, but other than that, I will probably be here. Yeah, thanks. Looking forward to see you too. Yeah, I think it's safe to say that there will be no more questions. Again, thank you everybody for coming, and see you on the main event. Goodbye.